All right, we're going to go ahead and get started here on homework number 8. And it is called Translations and Transformations. So in this assignment, we're going to be talking about families of functions and being able to transform them using vertical translations and horizontal translations, things called vertical stretches, compressions, as well as reflections over the x and y axis. None of that probably made sense if you had never heard of it before, and that's okay. We're going to learn everything. So the best way that I'm going to start off teaching you is by going through these problems and explaining it as we go, and then taking steps back and explaining what I did. So if you look at problem number 1, number 1 says, how is each function related to y equals x? So I'm going to stop there and say, all right, so y equals x. This is going to give me a line. And the way that I can tell it gives me a line is that no matter what x values I put into a table, if I say x is equal to 0, I know my y value is going to be 0. If I say x is going to be 1, then I know y is going to be 1. I could choose any value I wanted, and it would be the same because it's saying y is equal to x. Whatever value I put in here on the left in the x is going to be the same as the y. So if I were to graph y equals x, right? Let me see if I can make that line a little better. Yeah, I'll make it straight. All right, and then I'll draw another line this way, straighten that up. And I'm going to label, this is my x-axis, this is my y-axis. I'm going to plot the points that I have here. I have 0, 0. I have 1, 1. I have 2, 2. If I were to go ahead and connect these and draw a line, I can say this line is y equals x. Okay? So this is what the graph of y equals x looks like. From left to right, if I'm moving from left to right, it's moving in an upwards trend. Okay, so this is the graph of y equals x. This graph will never change, meaning that if y equals x, if I were to tell you to graph y equals x, the graph will always look like this. That's why when I grade your tests or grade anything, your quizzes, and I'm looking at, even your homework, I'm looking at these problems, I make my answer key and then look at yours. Yours should look exactly like mine. Your graph should not have like a line like way over here. It should look like this. So if I know y equals x looks like this, I can then move the different points around different locations and be able to look at a new graph of the line and see what I did in order to make it look like that. So when I say that, we know y is equal to x here. The very first question asks, how is each function related to y equals x? How is it similar? What happened to it? So it says graph the function by translating the parent function. In this case, y equals x will be my parent function, right? That's important. Okay, some of you skip through the video and don't actually listen to what I'm saying and just look for the answers. You have to pay attention to the lesson part because this is where things are going to start getting more difficult. This is the parent function. Y equals x is my parent function in this case. Sometimes the parent function might be different, but for this problem, it says y equals x is our parent function. So now that we have that, it says how is each function related to y equals x? And then graph the function by translating the parent function. So number 1, it tells me y is equal to x minus 3. Okay? And what we would do is, we would look at this and say, all right, y equals x. That's the same, but the new thing we've added on is minus 3. Our parent function looks like this, and then we subtracted 3 from it. So what does that mean? So, actually, every single time that you are subtracting outside of our parent function, so this is our parent function here, but we're subtracting 3, or subtracting any number, no matter what the number is, that means we're actually going to move all the y values down 3. Okay, so this minus 3 on the outside means we're going to move it down that many units. In this case, it's down 3 units. So without even going to my table, I'm going to do this first, right? So it wants me to graph it. I'm going to move all of my points down 3. So I start my first point here. Remember that was 0, 0. This was 1, 1. And this over here was 2, 2. Right? If I go through and move all of my points down 3, I move this down 3. 1, 2, 3. Move this one down 3. 1, 2, 3. Move this one down 3. 1, 2, 3. And if I graph this line, notice that it's still parallel to my previous line, but all the points have been moved down 3. Now check this out. If I were to look at this, this new point is 0, negative 3. This one is 1, negative 2. And this one is 2, negative 1. Now, this I was able to graph this without even making a table. And the way I was able to do that is just take, knowing that I know what the parent function looks like. I graphed my parent function right here. And then just subtracted 3 from each one of the values. Subtracted 3 and went down 3. So watch this. If I would have taken the time, and this was the longer way, if I were to take the time and go through and graph these points, right? If I were to say 0, 1, and 2, the same 3 points I did for up here, if I were to do that, 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. And check this out. Those 3 points, 1, 2, and 3, were the same exact points as 1, 2, and 3. So I was able to graph it without even making this table down here. I didn't even have to draw this table. And that's what I was anticipating in this problem. It said, how is each function related to y equals x? Graph the function by translating the parent function. Translating means, so if it says translate, that just means move, okay? So move it in one direction or another. So I noticed that everything was minus 3, so I just moved everything down 3. All my points moved down 3. Okay? And how is it related? It's related because it is using the parent function, and I'm subtracting 3 each time from it. But look at number 2. Number 2 gives me y is equal to x plus 4. Now, this is a plus 4 at the end, so I'm going to move all of my points up 4. All right, so I'm going to go ahead and graph it. Whoops. Maybe I'll do it on the same graph as up here. How about that? So I'll take my original and I'll move up 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right, so I'm able to draw my line here. and this was the graph of y equals x minus 3. This was the graph of y equals x plus 4. Okay, and if you look, all these lines are parallel, and I just took my parent function, I said y is equal to x, and moved it up 4, right? I really just added 4 to it. This was take my parent function, and then I moved it down 3. And that's all it's really asking for. It's really making you realize that all of these graphs are related, and that you can maybe find the answers easier rather than make a table for each. I could have made a table for number 2 and just said 0, 1, 2, and found my line. But you can look at this and just say, oh, plus 4, I know what y equals x looks like. Y equals x will always give me a line. So if I memorize that, oh, y equals x gives me a line, I know that this is going to give me a line from left to right in the same direction. So I just added 4, and that's all I did. Okay. Moving on. Number 3. Number 3 says, make a table of values for f of x after the given translation. Okay, and it gives you, this is what it gives you. It says x, and then f of x. Remember, f of x is the same thing as y in this case, right? So you're wondering, what's f of x? That's just y, x and y. I have negative 2, I have 0, I have 1, I have 3, right? So I'm moving like that, and I have 3, 1, negative 2, negative 1. This is what my table looks like. And it says, make the table of values for f of x after the given translation. Okay, so it wants me to add 2. It says 2 units up. So what we're going to do is we're going to move all of our f of x values, and we're just going to add 2 to them. So it would be 3 plus 2, 1 plus 2, negative 2 plus 2, negative 1 plus 2. All right? Yeah, those values are right. All right, so our new table would look like this. We'll say x, and we'll say, it's common, I guess. All right, this is where I'll introduce this. We have f of x here, and I'm going to take all this out. It's common to write, once you make your translations, it's common to call this g of x. All right, don't ask me why they chose g of x, but that's just a common way of writing it. It's basically saying, all right, I have my x and my y. This is my x value, really. This is my y value, really. And our transformation, what we're actually going to do, I'm going to add 2 to each, and I'm just going to call it g of x. You'll see it pretty often, so I'll go ahead and do this now and just teach it to you now. But you're just adding 2 units up, so give me 5. 1 plus 2 is 3. Negative 2 plus 2 is 0. Negative 1 plus 2 is positive 1. Okay? It doesn't tell me you need to graph it or anything like that. Number 4. Number 4 gives me x is negative 1, 0, 2, and 3. Okay, I'm going to go ahead and draw my table here. And I'll save room for my g of x at the end over there. But it gives me f of x, or really my y value in this case. And I'll go ahead and write my g of x. All right, so I have 1, 0, negative 4, and 2. And what it wants me to do is, it says I want to move it all 1 unit down. So before, 1 unit up, I added 2 to everything. 1 unit down, I'm going to subtract 1 from all my f of x values. So 1 minus 1, I'm taking these values right here. Okay, 1 minus 1 is 0. 0 minus 1 is negative 1. Negative 4 minus 1 is negative 5. 2 minus 1 is 1. Okay? That's all it's asking for in that problem. Okay? Number 5, it says write an equation for each vertical translation. So it says y equals f of x. So in this case, it wants me to go ahead and move 3 units up. So the way I could write that, I could say y equals x, and I want to move it 3 units up. Think back to my very first few problems. I guess it was number one we moved 3 units down. Number 2 we moved 4 units up. In this case it says move 3 units up. I'm just going to add 3. Okay, that's simple. Number 6, it says move 5 units down. I'm going to take my parent function. Y equals x is my parent function. I'm going to move it 5 units down and subtract 5 from it. Okay? So, from here, number 7 says write an equation for each horizontal translation. Now, this entire time, we've been doing vertical translations, meaning that we've been moving up and down, right? Moving up and down, every single problem. Now it's saying we're going to start moving horizontally, right? We're going to move left and right. So for number 5, you may have also written it like this, right? You may have said f of x is equal to x plus 3, or f of x is equal to x minus 5. It's the same thing. I'll accept either one of these, right? If you circle that, I'll accept either one. It's the same thing. Y will be the same thing as f of x. But moving forward here, this is going to be important. It says, write an equation for each horizontal translation of y equals f of x. So we're going to move 2 units to the left. And even though we're moving now in a horizontal fashion, so horizontal will be left and right, right? So horizontal translations are different from the vertical translations we were just doing. So what we would do is, whenever we're dealing with a horizontal translation, we're going to have to use parentheses, okay? And whenever we want to move a number to the left, we're going to be adding. And whenever we want to move a number to the right, we're going to subtract. And that might seem confusing. It's just something you have to know. You might think to the right, well, why am I not adding if I'm going to the right? Those are positive numbers. You'll find out later, okay? So whatever your number is, I'll just say n for number, right? They'll be moving in that direction in that number. So if I'm saying I want to move 2 units to the left, I could say, well, I'll go ahead and just write it f of x, because you'll see that a lot. F of x is equal to, we want to move it to the left, so we know we're going to add, so I'll put it inside parentheses, and I'll say x plus 2. All right? And then I'll do number 8. Number 8, I'll start off with f of x again, equals, I have my parentheses. And right now, just trust me, add the parentheses now will make things easier in the future, okay? So it says, write an equation for each horizontal translation, and it says 4 units right. Remember, right, we're going to be subtracting. So we would subtract, and it says 4 units, and we subtract 4 units that way, okay? And if we were to graph it, we would actually see that this works and would actually move it to the right, all right? So if you actually want to put it in your graphing calculator or you want to graph it yourself, that's fine. Trust me on this. This is a new concept that we're going to be talking about a lot. So just introductory here, just trust me on these basic steps. And sometimes you have to learn and experience some of these things first and start using them in a very basic way before learning what they actually do and why you're doing it. For right now, all you need to know is whenever you're moving something to the left, you would add parentheses and just add the number, whatever that number is. So that's how we did number 7 here. If you want to move something to the right, you subtract it by whatever number you're asking for, okay? So far, pretty basic stuff. You might be wondering, why am I doing this? It will all make sense, okay? Promise. Number 9. It says, write a function rule. For each function, reflect in the given axis. It says, write a function rule for each function reflected in the given axis. That makes sense. All right, so number 9 is f of x is equal to x plus 1. And we want to reflect it over the x axis. Okay? So what that would mean is, if I were to look at the first bit of the homework in homework number 8, I have a few pictures there. And you see the vertical translations we just talked about, the horizontal translations, but then talks about vertical stretches and compressions, and then also reflections. So it says there, if you read it, it says, for reflections in the x-axis, you're going to just put a negative out in front of whatever your value is, okay? So put a negative for the x-axis. So I'm going to come down here, and for number 9, I'm going to go ahead here and say f of x is equal to, remember, I'm flipping it, I'm putting a negative out in front. All right, so whenever you're reflecting over the x-axis, you're just going to put a negative out in front. And from here, I can distribute this negative to my x and to my 1. So I can say f of x is equal to negative x minus 1. All right? And then for number 10, I have f of x is equal to 3x minus 2. And I'm going to reflect it over my y-axis. And what I would do for everything reflected over the y-axis, I would turn the x negative. So what I mean by that is, whenever reflected over the y-axis, I would still write what I have, but turn the x negative. So what that would then do is, I would say f of x is equal to, well, 3 times negative x gives me a negative 3x minus 2. Okay, so if you're wondering, well, what am I reflecting over the x-axis? What am I talking about here? Well, if I were to graph it, right? If I were to graph this and have f of x equals x plus 1, remember we remember what f of x looks like? F of x starts here and goes right through 0, 0. You guys remember that? Well, if it says I'm going to add 1 to it, this was, I'll go ahead and draw another line. I'll say through 1 here. I'll draw a line that goes through. Maybe I should have started in a different place. Maybe I should have started down here. Right, a line that's kind of parallel. There you go. So if this is this is y equals x, and this is y equals x plus 1, right? And you want to reflect it over my x-axis, right? And you want to reflect it, it would actually end up going through a point down here and be flipped this way, like looking through a mirror, right? And that's why they say reflect over the x-axis, if you're looking at a mirror from that angle. And if you were to graph it, whenever you have an x-axis, whenever you're reflecting over the x-axis, you would make sure to put a negative out in front, just like we did in this step right here. Okay, so that's whenever you're reflecting over the x-axis. Whenever you're reflecting over the y-axis, you're going to put a negative in for x, and then solve it and get down to this, what we have right here. Okay, so that's number 10. Number 11, it says we're going to do a vertical stretch, okay? Vertical stretch by a factor of 3. So I'll say vertical stretch by 3. And a vertical stretch actually takes a graph. Let's say this is my line. Actually, I'll do it up here, right? A vertical stretch takes, let's say I have a line that looks like this. A stretch would move it closer, like more of an up and down line, right? You're stretching it vertically. You're making it longer going that way. So how do we make a vertical stretch by 3? Well, what we would do is we would just put 3 outside of our parent function. And in this case, our parent function is y equals x. And it's saying we're stretching it by 3. So a vertical stretch, you would just say y is equal to 3x. And that's how we would stretch it vertically, is by putting a 3 out in front of whatever the parent function is. That's a vertical stretch. Okay, then it says a vertical compression. A vertical compression by factor of 1/2. So the same thing, by a vertical compression, I would take my parent function, which is still y equals x, and just put the 1/2 out in front. And that's how I would actually compress y equals 1/2 x. And a compression, what a compression looks like is, if I draw my line over here, I'm graphing it, right? A compression would actually make the line flatter, where a stretch would make it more up and down. So a stretch would make the line more vertical, and a compression would actually make the line more horizontal. Okay? So moving on, we're going to move to number 13. Number 13 asks you to write a function rule g of x after the given transformations of the graph. So it's giving you f of x is equal to x. Okay, so just like how we have our y equals x graph, it's the same thing, right? So just think this is y equals x. Remember what y equals x looks like? It's a line that goes through 0, 0, from left to right, moving upward. So it's saying for number 13, we're going to translate it up 5 units. Okay, so as we've learned already, we're going to take what we have and we're going to add 5 to it. And that's how we move it up. Number 14, remember my parent function is f of x equals x. And say we're going to translate it down. So my first step is to translate it down 7 units. So I say subtracted by 7. Then it says a vertical stretch by a factor of 4. Remember, whenever we do a vertical stretch, we just put the number out in front of the x. So I can say the vertical stretch by a factor of 4. That would be my answer for number 13. This would be my answer for number 14. Number 15 says a translation. So I'll start with f of x is equal to x. That's what I'm starting with. A translation up 2 units. Okay? And then the reflection in the x-axis. And if you remembered, the reflection in the x-axis would be by putting a negative out in front and then distributing that negative across. So f of x equal to negative 1 times x is negative x. Negative 1 times 2 gives me negative 2. Okay. That's what I got. And that's how I get number 15. So by memorizing these, you're able to use it quicker. You'll always have this cheat sheet to look at. And you have to remember that, f of x, if I'm looking at my parent function, f of x is equal to x, right? Which is the same as y equals x. If I were to look at it this way and say, all right, x plus 2 moves it up 2. X minus 2 moves it down 2. And we'll talk more about left and right and horizontal shifts. But as you see, I can move this, and then if I want to stretch it, right, I can put a 2 in there. If I want to be able to compress it, I could put a fraction in there, and that would make it smaller. Okay, a negative out in front gives me a gives me a horizontal shift, and a negative in the x gives me a vertical shift. So we'll be using these frequently. Like I said, this is just introductory, so you don't have to memorize this stuff right now, but just follow along right now, and you'll be okay. Moving on to number 16, we're going to start talking about absolute value, and we're going to deal with a new parent function. So I'm going to go ahead and move to number 16 here. Okay, so the new parent function we're dealing with, it was f of x is equal to x. The new parent function we're going to talk about is f of x is equal to the absolute value of x. Okay, so how can we deal with the absolute value? So you might see it written like this, right? Y is equal to the absolute value of x. And we talked about absolute value before, so you guys know what absolute value is. And it follows a lot of the same patterns that we've been using. So check this out, number 16. It says y is equal to the absolute value of x plus 1. Make a table of values for each equation, then graph the equation. Okay, so I'm going to go ahead here and do that. I'm going to give you, and now check this out, whenever you're done with absolute value, you want to use at least 2 negative values. I'll say when graphing absolute value, you want 2 negative numbers, and you want 2 positive numbers. And your hope is also to find something called the vertex. We'll talk about the vertex here shortly too. So I'm just going to pick negative 2, negative 1, 0, 1, and 2. So I have a couple negative numbers and a couple positive numbers, and I got 0 in there because that's easy. All right, so I'm going to go ahead and substitute these values in, and let's say negative 2, the absolute value of negative 2, taking this and just plug it in here. The absolute value of negative 2 is 2. 2 plus 1 is 3. Absolute value of negative 1 is 1. 1 plus 1 is 2. Absolute value of 0 is 0. 0 plus 1 is 1. Absolute value of 1 is 1. 1 plus 1 is 2. And then absolute value of 2 is 2. 2 plus 1 is 3. Okay? So if I wanted to graph this, go ahead and draw my line. And I'll draw another one here, right? And I'm going to plot my points. I'll say negative 2, went up 3, 1, 2, 3. And we had negative 1 up 2, 0, 1, and 1, 2, and 2, 3. And if I were to draw a line here, it goes through my points. Notice that we have a V shape. So I'm also going to say, and I'll put a big star next to this so we'll remember it, when graphing absolute value, you will goodness gracious, always get a V shape. Okay? You always get a V shape graph. If you don't get a V shape, you messed up somewhere. Okay? There should always be a V shape that looks like this, right? So when I'm looking at this, okay, I want to start to identify what different pieces are. This right here, where it changes directions, this point, which is 0, 1, that is called my vertex because that's where it changes directions. Notice that in this case, it's going forever left in that direction and forever right in that direction. That point where it changes is called the vertex. Goodness. I'll say the vertex. And that's at 0, 1. This is my y-axis, and this is my x-axis. All right, so when you graph it, it's not asking for the vertex right now, but it will eventually will to identify where the vertex is. In this case, it's right there. Okay. Number 17. Number 17 gives you y is equal to the absolute value of x minus 1. Make my table of x and y values. Say -2, -1, 0, 1, and 2. And then go ahead and draw this. Make my table. And I'll say, all right, I'll go ahead and add each one. -2, the absolute value of -2 is 2. 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. Okay, so I can now graph. Let me do this, move it this way, and I'll go ahead and graph that way as well. I'll just add that. I have my y-axis and my x-axis, and I have -2, 1, so -2, up 1, -1, 0, 0, -1, 1, 0, and 2, 1. Right? So you could go through this way and graph it and know that the graph of this is y equals absolute value of x minus 1. But if you were to graph just y equals the absolute value of x, that's going to be a shape that looks like this. Okay, so this would be y equals absolute value of x. And notice that the translation of y equals absolute value of x has been moved down 1. So we've been graphing this whole time using this table, right? We've been creating these tables where really the concepts of what we learned in our last lesson without absolute value also translate here too. Okay, in the last example, it was y equals the absolute value of x plus 1, and all of our values were above it. Now we have minus 1, and they're all below the parent function. Okay, so number 18, check this out. We have y equals the absolute value of x plus 2. If I go ahead and create my table here, like I said, I like picking -2, -1, 0, 1, and 2. Okay, negative 2 plus 2 is 0. The absolute value of 0 is 0. Negative 1 plus 2 is 1. The absolute value of 1 is 1. 0 plus 2, the absolute value of 2 is 2. 1 plus 2, absolute value is 3. And then 2 plus 2, the absolute value is 4. If I were to graph this, check this out. This is where you start to run into some interesting, I wouldn't say problems, but you end up seeing that I'm going to have to keep working. Remember that all my absolute values should be a V shape, right? Remember I told you that? Well, check this out. So if I graph this, I have negative 2, 0. I have negative 1, 1. I have 0, 2. I have 1, 3. I have 2, 4. Now, this is giving me a line. So if I'm expecting a V shape, I want to plot more points this way. So that way I can just double check and make sure I'm doing everything correctly. So I'm going to go ahead and keep going in this direction. And the first point that I have here is negative 3. And if I were to add that, right, I could say negative 3 plus 2. Negative 3 plus 2 is negative 1. The absolute value is 1. So negative 3, 1. And now I start to see a trend in the other direction, right? And if I were to even plot one more, you don't have to, but you could if you really wanted to. Negative 4 plus 2 is a negative 2. The absolute value of negative 2 is 2. So that would give me a negative 4 up 2. Right, so that then kind of gives me the V shape that I've been looking for. Right. That's not the best line. I'll draw another one. Okay, so I was able to plot all those points and realize that I added 2. Remember when I added 2 inside parentheses, that moved it to the left 2? Well, check it out. I've moved my vertex from 0, 0 over 1, 2. So my parent function, which started off looking something like this, has been shifted this way 2 units. So 2 units to the left, it's been shifted. So that's important because as we go through and you start making these table of values, you're going to get kind of bored of doing this over and over and over again, creating these values. But the purpose and the reason why I've added so many of these on here, and you have 5 of them you have to graph, is that you go through and realize what you're doing. So for number 19 and for number 20, right, you're going to go in and you're going to graph those problems, okay? And once you actually get to, I'll go ahead and skip through number 19 because 19 is going to be very similar to number 18, where instead of number 19 says y equals x, absolute value of x minus 2, I know all I'm going to do is I'm going to take my parent function, which is y equals the absolute value of x, and I'm going to move it to the right 2. So I could save time here. Instead of making that table of values, I encourage you to do it. I'm just showing you, right? So if I want to move it right 2, this was my original parent function, it would be moved over to the right 2 and would start there. Okay, so I encourage you to do it the way it asks you. I'm just skipping over that because I'm going to go ahead and just create another table and just take a while. I want you to eventually realize that there's an easier way of doing it. If you've memorized the fact that every single time there's a minus 2 inside parentheses or absolute value or anything like that, on the inside, you're going to move it to the right 2. If I were to have a negative 2 on the outside, that would move it down 2, right? But on the inside, it's going to move it right 2. If this was a plus, then it would be to the left 2, but it's not, it's a minus. Okay, so number 20, I'll go ahead and go through this one. Y equals absolute value of x minus 3 minus 1. So on this one, check this out. Remember I said when you subtract, you're going to move to the right. So this, from the parent function, y equals x, I'm going to move it right 3, and I'm going to move it down 1. And I know that because of the negative 3 there and the negative 1 there. So for my parent function that I started with the vertex at 0, 0, right? I can move my vertex to the right 1, 2, 3, to the right 3, and down 1. And if I were to make a table of values, right? If I were to make that table of values for number 20, I guarantee you, your shape is going to look like that. This is going to be your vertex here. Okay, your vertex is going to be at 3, negative 1. I don't know why it's starting to look like that. It looks, there you go. Okay, so you could go through and make your table of values and do all that. That's the point of doing numbers 16 through 20, is to do your table of values and realize that this is time consuming and your time is valuable. So how can I make this easier for you? Well, how do you fix it? The way you can fix it is by learning the translations and the transformations that we're talking about. And all these translations and transformations can be found right here in the homework document as well. The family of absolute value functions. There's a picture there that talks about vertical translation, horizontal translation, vertical stretch and compression, as well as the reflection. Okay? Only got 5 more problems. Number 21. Number 21 says, graph each equation, then describe the transformation from the parent function. So my parent function is still f of x is equal to the absolute value of x. Okay, so it says to graph it, then describe the transformation. I'm going to do this. The directions tell you to graph it. I am not going to graph it. I'm going to let you graph it. Okay, because I've described what these are going to do. It says the 3 out in front, okay, then describe the transformation. We've actually added a number out in front, the 3, and the 3 out in front gives it a vertical stretch of 3. It looks like this, f of x is equal to 3 times absolute value of x. Okay. What's going on now? I changed the color on me. I'll use this. 22. It says well, I'm using the same parent function, f of x is equal to the absolute value of x. And then from here, it's giving me f of x is equal to negative 2 times absolute value of x. All right, it says y, but I'm just going to use f of x. So there's 2 things that it did here. First, I see a vertical stretch of 2. That's the first thing I see. And the second thing I see is that negative out in front. And that negative out in front is a reflection in the x-axis. Okay? When you have that negative out in front, you know there's a reflection of the x-axis. That's 22. 23, my parent function is still f of x is equal to absolute value of x. And number 23 gives me f of x is equal to 1/4 times the absolute value of x. So what have I done here? By putting it in a fraction, if it's a number, if it's any integer, or any number greater than 1, right, then you have some sort of a vertical stretch. But since this number is between 0 and 1, it's going to deal with a vertical compression. Okay, so a vertical compression of 1/4. Okay, and if you were to graph it, you would see what that looks like. And I encourage you, the numbers 21, 22, and 23, please graph them, right? So you still have to graph. I did not graph them, but you still need to graph all of these. All right, and the way you would graph it is just by creating your X and Y tables and going through and taking your time, entering in values and updating that. Okay. Number 24, it says, without graphing, identify the vertex, axis of symmetry, and transformations from the parent function. So we've talked about all this except one thing. We've talked about the vertex, we've talked about the transformations, but we have not talked about the axis of symmetry. So check this out. If I had, imagine this is a nice straight line, right? If I had a V here, right? And I wanted to create an axis of symmetry, I would draw it right down the middle, right? The same way as if I had like a circle. I wonder if it'll make it look nice, yeah. And I wanted to make it symmetrical. That line is called my axis of symmetry, right? And you might see me abbreviate it as AOS for axis of symmetry. But in number 24, right, it's asking me, where is that axis of symmetry? Well, I'll show you how to do that here. So number 24 says y is equal to the absolute value of x plus 2 minus 4. Okay, so I know when I'm first looking at this, the things I need to identify, it says identify the vertex, I need the axis of symmetry, and I need my transformations. Okay, so the vertex, the way I can tell where a vertex is by looking at the equation, right? You can say y is equal to a times the absolute value of x minus h plus k. Okay, so if I'm looking at this and I see that this looks a bit different from this, right? That's minus h, and that's plus 2. So a vertex will always be located at hk, which means that my vertex is going to be this. So my vertex in this case, I'll go ahead and just plot it just to show you, right? If I were to pick some points here. I don't know, I'll say -4, -2, 0, 2, and 4. Just picking random points. If I were to go through and look at this, -4, I'm going to plug these values in. -4 plus 2 is -2. The absolute value of -2 is 2. 2 minus 4 gives me -2. Okay. -2 plus 2 gives me 0. 0 minus 4 is negative 4. Okay, 0 plus 2 is 2. 2 minus 4 is negative 2. So I already have seen a change, and I'm going to go ahead and do the rest of these. 2 plus 2 is 4. Absolute value of 4 is 4. 4 minus 4 is 0. And then 4 plus 2 is 6. 6 minus 4 is 2. So check this out. I know it says do it without graphing, but I want to show you with graphing first, and then I'll show you the easier way, right? So we've gone through, and we're doing it the graphing way, and we get tired of putting in all these table of values. So we have negative 4, 1, 2, 3, 4, down 2. And then we have negative 2, down 4. Sorry, negative 2, down 4, 1, 2, 3, 4. Say there. And then we have 0, negative 2, 0, negative 2. We have 2, 0. And we have 4, up 2. Let's check this out. So I have that absolute value shape. And realize that my vertex right here is at negative 2, negative 4. So check this out. By looking up here in this equation, I say, all right, just by looking at this, I could have skipped all of this down here. I could have skipped all this and just went ahead and just followed what this asked me, right? And said, all right, I have my h and I have my k. Well, it says minus h. This is a plus 2, so that means I had to deal with a negative number at some point. So I know my vertex is negative 2, and then there's a negative 4 all the way out there, so negative 4. And the reason why this would be a negative 2 instead of a positive 2, it would have been a positive 2 if this would have read x minus 2, but it doesn't. Okay, it says x plus 2. My axis of symmetry, if I go down to my graph, right, if I draw my line, is going to be going through wherever my x value is in my vertex. So whatever that x value is in the vertex, that's what the axis of symmetry is going to be. So it's going to be when x is equal to negative 2. And if I were to draw a line straight down x equals negative 2, that would give me my axis of symmetry. And what happened, what were my transformations from my original? Remember, my original parent function had a vertex right there. Okay, what we did was we moved to the left 2. It's because of this right here. And we moved down 4 because of this right here. Okay, so watch this. We're going to do number 25. And we're going to do it without graphing it, and then test it by graphing it. Okay, y is equal to 3 times the absolute value of x plus 6. Okay, and it asks for 3 things. It asks for my vertex. It asks for my axis of symmetry. And it asks for the transformations. Yeah. Okay, so my vertex, remember, if I'm looking at this, y is equal to a times x minus h plus k. All right, this is my equation I'm working at if I want to find the vertex. So I know my vertex is going to be negative 6, 0, because there is nothing out here, right? There's nothing, so I'm adding the 0 for k. K is going to be 0. If I find what h is equal to, say, okay, h is equal to negative 6, k is equal to 0. That's why I have my vertex. Remember, my vertex is always going to be at h. K, my vertex is negative 6, 0. My axis of symmetry is easy as just saying x is equal to whatever that x value is. So x is equal to negative 6. in my transformations, what I've done is I have a vertical stretch by 3, and I've also translation to the left 6 units. Okay. So those are my 3 parts. And if I went through and I chose some values, right? I don't know, just choose some. If I say my vertex, so, right, I'll go ahead and draw my coordinate plane. And if I said my vertex was at -6, 0, I'll go ahead and plot that 1, 2, 3, 4, 5, 6. I know my axis of symmetry goes through here because you told me that was my vertex, right? And then from here, I don't know, let's just plot a few extra points. I'll plot a few to the right and a few to the left. I'll do, I don't know, let's see where we're at when I say 0, right? When x equals 0. Okay, 0, no, that'd be too big of a number. Let's do, I don't know, -4. Okay, so -4 plus 2 gives me a +2. The absolute value of 2 is 2. 2 times 3 gives me 6. Okay, so -4, 1, 2, 3, 4, up 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so -4, up 6. I'll move to the other direction. I'll say -8. So -8 plus 6 gives me a -2. The absolute value of -2 is 2. 2 times 3 is 6. Okay, so if I go -8 up 6, as you see, that gives me that absolute value shape, the V shape, and there's my graph. And I really didn't even need that table. All I had to do was go ahead and find my vertex, my axis of symmetry, and realize the transformation. Okay, so it didn't ask me to graph it. It said without graphing, but the reason I went through the graph was to show you that you can do it a lot easier without even graphing, without looking at that. You can recognize these patterns, see what's going on, and do less work. So you're actually working easier and working smarter, not harder in these cases. Okay, this is just the beginning of this stuff, and some of it might seem confusing right now, and you might have just worked through these problems and not understand fully what you were doing, but we're going to be building on these concepts. I don't expect you to know all this right away. That's why we don't have a test on it yet. This is the first lesson that we have, and I'll be making sure to go back over this in detail over the next few weeks. So that was homework number 8.